Welcome to the dynamic learning hub of ExcelR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a light classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Want to get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. ExcelR. We don't just train, we build careers.
Yes, so the collaboration with ExcelR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
Good evening, everyone. I hope my voice is audible. Okay, so students will wait for five more minutes. Then we'll start for the day. Only 22 participants are there in our meeting, so we'll wait for 5 minutes. Then Sunil sir will start the session.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if ExcelR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with ExcelR was very smooth. They helped us in conducting the workshop smoothly, right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our technical fest Atmos, and I thank ExcelR for being a part of it.
Sunil sir, we can start
Yeah.
for today.
Yeah, thank you. Hi everyone, good evening. And so far we have worked on, we are working on different types of machine learning projects, and we started with regression problems, and then we worked on classification problems, and later yesterday we started working with clustering algorithms and forecasting solutions. So today, our prime focus will be on so far it's structured data, and from today we'll be starting with unstructured data. The difference between structured data and unstructured data is that in structured data we have a proper structure. Like for example, the data will be in the form of columns and rows in the tables, so that we can easily query that information, and we can apply different transformations on top of the structured data, etc. And apart from when it comes to unstructured data, what happens is we don't have proper structure, and it's not easy to query this information in such in a way similar to what we do with structured data. So that's why it's kind of difficult to deal with unstructured data. And in unstructured data, data like text data, video files, audio files, and um there is, yeah, I mean, you can consider these data as unstructured data. And there is another data called semi-structured data, which is partially structured and partially unstructured. Data structures like JSON format will be part of this unstructured data. So from today, we'll be starting with unstructured data. As part of this unstructured data course for today and tomorrow, my plan is to work on and to give you glimpse about what natural language processing is, and what are different approaches that happened so far, and what is currently happening in the industry. And when it comes to computer vision, I mean, dealing with image data, we are not going to deal with video data right now or speech data right now. So we'll be dealing with image data, and we'll work on image classification problem, and we'll discuss about convolution neural networks. I will try to give as much, I mean, as much as information that's possible in this session, because this particular deep learning is comparatively difficult to understand, because there are different concepts related to it. Like, for example, what is neuron, and what is a neural network, and what is neural layers, and what are the activation functions, and what is forward propagation, what is backward propagation, and what happens in forward propagation, what happens in backward propagation, and what is vanishing gradient problem, and how are we going to solve that one. There are different structures within neural networks, like recurrent neural networks, long short-term memory networks, convolution neural networks, and gated recurrent GRUs. There are multiple types concepts related to this particular deep learning. And so it itself is an very big concept, and requires a lot of time, but I will try to give you whatever is possible within these two sessions. And other thing I want to cover is, I want to give you a glimpse about what are these language models. You might have been hearing about chat gpt and language models in the recent times very frequently, because there is a lot of buzz created around them, and most of the roles you have been seeing. I mean, I'm not sure whether there are roles that are being posted for freshers. But majority of roles recently, there's a lot of demand for this particular language expertise in language models. So that's why I will give you a glimpse, but you need to go through in depth about these language models and try to understand how they work, and the solutions you can build using these language models. So coming to deep learning and natural language processing, whatever the topic techniques we will discuss right now, were being used before concept of transformers was introduced. But the concept of transformers, or this concept of language models, has some interlinkage with the techniques or with the approaches which were used earlier. And in some ways are in some cases are in to solve some of the problem statements, these approaches are being yet still used. Because the problem with these transformers or the language models is that they are resource hungry, and they need a lot of resources. To solve a small problem using a language model is not that cost effective, and at the same time they are costly as well. They are not very cheap to run. And even to run and to fine tune a transformer model like BERT, you need to have a GPU if the data is big enough. And so obviously when you are going with GPU, you will be encountering more cost towards using the GPU. So that's why it's not like the techniques which we will be discussing are not being used in the industry. They are being still used, depending upon the problem you want to solve, and the resources you are ready to spend. You will be making decision. But obviously, the performance or the quality of quality of response will be very high for language models when compared with earlier approaches. So let's start with theoretical part first, and then we'll go with practical application. Today we'll in the project part, I will try to. I will be adding. I will be showing you sentiment analysis by using polarity approach. I mean polarity scoring approach, and then TF-IDF vectorization approach, and then we'll try to use a simple neural network to see how a neural network will work on this sentiment analysis problem. And after that, we'll see what happens when we change the simple neural network to an LSTM network, and then we'll be using this transformers based robota model to understand how well this particular textual classification problem is working. And after that, I will show you how you, I mean, instead of doing all this by just using Hugging Face models, how you can directly predict the sentiment instead of training the model on your own. Because right now Hugging Face is providing you models are directly available with you. You can use an API call to call these Hugging Face models, and then just pass your text so that the sentiment, or if you want to do name entry recognition, it can be already by default done by the existing model itself. In some cases, what happens is like you might need to use an approach called um, one shot training or few shot training, where you will pass some examples to the model to tell like this is the way to teach it, this is the way you need to think, this is the approach you need to follow while making a decision, or while giving the output, or while giving the response to the problem statement. So that's how this works. So let's start with deep learning. Deep learning is a subset of machine learning, where the model tries to mimic human brain, and it uses components called artificial neural networks, or neurons, to solve complex problems by learning from huge amount of data. So this is an this is purely inspired by the structure of how a human brain works, and it will contain different neurons, or ANNs, or artificial neural networks, that are stacked in layer like structure, and multiple layers of such kind are used in order to form a network, where each neuron will try to interpret the information that is being passed to it in a different way. And then it uses it based on that information it learned, it will calculate some values, and then send that information to neuron in the next layer, which in further tries to understand its own way, and try to calculate some values, and then pass that to next neuron in the next layer. So this is how every level will understand a different concept from the data that is being passed to this network. And so that it will become easy for, I mean, it will the model will be able to understand insights, or the patterns within the data that is being passed to the network, and based on that the model will be able to make predictions on top of that one. If you look at this particular this image here, so if you look at the left side of image, this is how our this is one of that what do you call, one of the neuron communication option, I mean one of the neuron how in our brain. And if you look at the structure of this particular ANN, it is also, it similarly resembles our neuron structure. So if you look at this extended this outlet outside structure within this neuron, we can observe there are dendrites that are being spread across from the particular point, which are considered as input. I mean, they are responsible for collecting the stimulation or stimuli from to an event, and then that information is being passed to neuron, which does some electrochemical complex equations and calculations, and then send the response through a connection to next neuron. So, and it continues like this, and based upon this information, an action or response will be stimulated. Like for example, when we touch an heat plate, the receptors from our skin, or receptor from our skin, will pass this information to a neuron, which will further calculate and then pass to next level, and to the next level. And finally that image that information will be understood by our brain, and then a stimulation or response will be generated based upon this information. Similarly, what happens in case of artificial neural networks is it will take some information, and every neuron will take some information, and then it will calculate a linear function, and after calculating the linear function, an activation function will be applied on top of this function, and then the generated output value will be sent to next neuron in the next layer. So the input for every neuron which is in the first layer will be the input values that are coming from from our input values. Like for example, we have some text data. Let's take we are trying to do sentiment analysis, and we have data like I like the movie. So what happens is like I will be one input and liked will be one input and movie will be one input, and this input will be converted into embeddings which will be further sent to this particular neurons through through some weights. That means the value will not be directly sent to the neuron directly, but every neuron from every input will be associated with one weight, and that weights are nothing but these W weights, and every input will be having its unique and individual weight that will be connected to one neuron. And if the same input value is connected to another neuron, then it will be having a different weight. So this is how these input values input data is connected to these neurons through these weights, and then there will be a bias term in order to deal with the error value. So ideally, what we are trying to calculate is these weights and values for these weights and biases through backward propagation, like by making the changes to the weights. What is the impact on the prediction? Am I doing it in the right way or not? Because we have training data. For example, when we are dealing with sentiment analysis data, we'll initially the data will be passed to the neural network, and then it will generate some response saying like it's a positive in sentiment. Then in the backward propagation, we know that the sentiment actually was neutral one. So what happens is like it will make adjustments to the weights and try to make the response to suit the actual response. This I mean, it's not like actual way, but this is how it operates. And finally what happens is like the weights will be calculated in such a way that this will ideally understand the data that is available with it, and the way it has to make predictions on top of unseen data. So that's how these neural networks work. And if you look at this kind of neural network architecture, if you look at this one, this this grade one in the the first column or first vertical line, which you can see here, is the input layer where input data is passed to the neurons in hidden layer. So what happens is like this second, third, fourth, and fifth vertical columns are hidden layers. That means transformations are being applied in this hidden layers, and whatever the calculations that are being done will be done within these hidden layers. And then there will be final layer called output layer, and this output layer varies depending upon the problem statement. For example, if our problem statement is an binary classification problem, let's say we are trying to predict an email classification algorithm, where we want to predict if a particular email is spam or not. So either it will be in our case, the output will be spam or not spam. So this will be a binary classification, and the final neurons in the output layer will be only two, because we want only two prediction. I mean, we have only two classes, and we want output from that particular two classes only. So that's why we have only two neurons in the output layer. But when it comes to multi-class classification problem, like for example, let's take a sentiment analysis, or let's take a classification itself, where we want to predict let's say document classification, where we want to segregate documents belonging to science, physics, maths, language. So what happens is like we have four classes here, and in order to predict four classes, what we need is we need four neurons within this one, because ideally what happens here is that this will finally will have some probability scores associated for this neuron and for this class here. So if this particular neuron, this class has highest probability value, then this will be the output for us. And if this has a highest value, then this will be the output for us. When it comes to multi-class classification problem, we will be having that many number of neurons in our output layer, as many classes that we want to predict. when it and when it comes to hidden layers, what I mean is like this is the place where we try to make changes and alter the structure of our neural network. And this input layer is also fixed because the data that we are passing is fixed. Here you can get the doubt that, let's say, when we are trying to predict sentiment analysis, we let's take we are predicting Twitter sentiment analysis. So somebody might be writing 143 words, whereas somebody will be one tweet might be having 140 words, whereas another tweet might be having 120 words, another tweet might be having 30 words, or some other tweets might be having only 10 words. So how can we fix this input layer? So the answer to this question is that we try to what we ideally do is we try to take the maximum length of the text that will be passed to our neural network, or simply to make it simple, we take the length of largest tweet and then use that length as our input layer. And what we can do is, in order to deal with the tweets which are having less number of words than the largest number, what we do is like we add the common some values like 000 or 111. We just add that value so that those particular value doesn't have any impact on making the prediction, because those are zero values and will not have an impact on altering the decision of our neural network. So that's how we try to adjust our length of the tweets. There is a term for this one. I will tell you this as we proceed. The length of input layer is fixed by the data or text which we have, and the length of output layer will be fixed by the problem statement which we are solving. So the thing which we can alter or we can make changes to is the hidden layers. So if you want to have 100 neurons in initial layer, or an uniform neural network architecture, what you can do is like, let's say you want to use 100 neurons in each layer and you want to use 5 layers. So what 5 hidden layers? Then what you can do is like you can use 100 neurons in each layers and create 5 neurons in each 5 layers within the structure, so that the structure looks like this will be input layer, and in this layer you will be having 100 neurons. Here we can see only 4 neurons, but there will be 100 neurons if you decide to go with 100 neurons. And even this will be having 100 neurons, this will be having 100 neurons, and this will be having 100 neurons. So that's how you can alter your neural network architecture. And if you observe this one, in general, what happens is like, I mean, if you are not performing pruning, or if you are not performing regularization, or if you are not performing some other techniques, then what happens is like, ideally, I mean, in general, every neuron is connected to every neuron in input layer, and every neuron in next layer is connected to every neuron in previous layer. So that's the basic general structure or architecture in which these neural networks are built. But if you observe this case here, it's not the case, because we generally disconnect some of them because of overfitting issues, or if we want to prune something, deal with to reduce the number of parameters the model has to learn. We can deal with this. We can adjust the weights. We can remove some weights. We can make some weight zero, so that the connection will not be established within that one. I mean, there will be different techniques to control the connections between different neurons and different layers. And again, when it comes to neural network, or when it comes to recurrent neural networks and LSTM, they operate in a different way. That neural network architecture will not look like this, but and because there will be only one layer, and when what happens is like this output from this will pass in a different way rather than this in this structure. But ideally, it when you look in the eagle point of view, it will look like the similar structure. But what happens actually is we are not creating multiple layers, but the outputs from every step will be passed to the next step, so that it will try to understand what is the important information I have to remember from previous step, so that this particular in that particular step, or while making decision at this step, what is the important information I need to remember. Because one of the major problem that happens in neural networks while dealing with text data, particularly in text generation or question answer systems, is that that particular if you have 100, let's say you have 30 to 100 layers within the structure within your network, then what happens is like and the text data is coming like you are passing around 500 a text with 500 words to the network. And what happens is like the initial words or initial information that is being passed to the neural network will be forgotten by the network. And what happens is like it will completely ignore that information. It will just focus more on this current latest information. And because of which, what happens is like it will not be able to work effectively, which is called as vanishing gradient problem. This happens because of the derivatives, and this happens during the backward propagation because of small values of derivatives that in small values of derivative multiplications. So because of which this issue arises, and to deal this with this one, RNNs and LSTMs were introduced, but still RNNs were also facing this issue. So LSTMs were comparatively better when compared with RNNs, and will try to capture majority of information. But when it comes to transformers, this overcame this particular issue. And at the same time, this transformers architecture were built in such a way to understand this information, understand a particular word, not just in one context but in multiple contexts, so that based upon the context it will be able to understand what you're trying to convey, and based on that it will be able to generate response. That's why if any of you have been using this chat gpt, you can see that you can see that based upon the way you ask a question, the response will be changed. So that's how it tries to understand the context, and based on that it will be able to generate the response. And if you look at this one, yeah, it's almost similar structure, so I don't think it is required. You can see here these weights and all in this particular neural network. Coming to this one, yeah, this is what internally happens. What we try to do is we use this input and calculate the linear equation and apply the sigmoid or any linear transformation on top of that one to make it linear. Apply this non-linear transformation on top of this linear function to make it non-linear, and to ensure that it captures non-linear information from the data that is being passed to it, and that is being passed to next layer, and where again similar thing happens. So ideally, each neuron will be calculating the linear relationship between the data, and then we capture nonlinear information from this activation function, and then pass that to final layer. Here in the final layer, we apply this transformation, and then we try to see what is the output based upon the output that's being generated by this output layer. Anyone, any questions so far? I'll wait for a minute to see if anybody wants to raise any question. I'll take that as a no. And now going to basic components of this neural network. Major components in neural network are input layer, hidden layers, output layer, weights and biases, and activation functions. So input layer, as I already mentioned you, the raw data that's being sent as features, and each node in this layer represent a feature of the input data set. Feature is nothing but, if you take text data, it's a word. And if you take maybe that might not be word also. So in some cases what happens is like if you are applying stemming and limitation, then what happens is part of the word will also be can also be a feature here. And when it comes to image data, the input feature might be like the pixel value in that particular region. And so it can be the feature, feature input that is being passed from our data. And hidden layers are the layers where real computation take places, and every neuron in hidden layer is consists of weights, biases, and activation function. So whenever it connects with another neuron, or when connects with output neuron, or when it connects with the input text feature, then it will be obviously connecting with the weights, biases, and activation function. And once it calculates the linear equation, then it will apply activation function in order to transform it into non-linear form. And output layer is a final prediction. So for example, as I already mentioned, in classification we try to predict the classes, and weights and biases are the strength of the connection between neurons. So what happens is like based upon the value, we will be able, I mean, it will be able to make decisions like what is the importance I need to give to this particular information that I'm taking from previous neuron, or from the data value, that data feature value that is being passed to me. And activation functions, they are nothing but we use them to introduce nonlinearity to the model. Because as I already mentioned you, the transformation, the calculation we do is linear calculation, and then we need to convert that into nonlinear. So we introduce this nonlinearity to that linear equation, and then use that information in order to make our predictions. So how these neural networks work? So there are three concepts in major concepts in neural networks. One is forward propagation, where input data is passed through the network layer by layer. For example, input data is first passed through all the neurons in first layer, and linear equation is calculated, and then nonlinearity is applied on top of that, and then the outputs are passed to next each neuron in next layer, where each neuron is associated with the individual weights depending upon from where it is coming, individual weights and biases. So based upon this weights, what happens is like the importance, or it will understand what I have to do, and I mean, for which thing I need to give more importance to. So this nothing but it's weight sum of all its inputs along with bias. Like for example, let's take x1 as our feature. Yeah, let's take this for a second. Yeah, let's take this one. So this is x1 our input, this is x2 our input, x3 and x4. So ideally, what happens in this sigma is that what we are doing is, let's take this first the x1 to this first neuron connection has a weight of w1 and bias as b1. So what ideally we do here is we calculate w1 x1 plus b1, and we take this x2 and we are passing this x2 to this sigma, and here what we are doing is we are calculating W2 X2 plus B2. And similarly, this X3 is being passed to to neuron 1. So we calculate W3 X3 plus B3. Similarly, same for X4, W4 X4 plus B4. And once we have this one, we apply some nonlinear activation function like sigmoid, or tan H function, or ReLU function, or something like that. And then this value again will be sent to this function. Let's give this value as this weight value that is being connecting this first neuron to this second neuron as w2, and bias as b2. So what happens is like the value will be w2 b2 sorry w2, whatever the value output from this one. Let's say output is o1. So the equation that we'll calculate here is w1 o1 plus b2, because b2 is the bias of this one. Similarly, we do the same thing for this one also, and finally this value is sent to here, and here final transformation is applied. And one more thing is the activation function that we use in output layer will be restricted by the problem statement. Like for example, it's binary classification problem, then generally the sigmoid function is used as activation function. And depending upon your problem statement, in most of the cases your activation function in your output layer is restricted to whatever that, I mean, depending upon the activation function is decided based upon the problem statement you are going to deal with. So yeah, that's what happens in forward propagation. This is how initially all the values are passed through each network, and then we calculate some weighted sum of its inputs, and then pass through, and then apply this nonlinear activation, and then pass to next neuron. And when it comes to backward propagation, before calculating backward propagation, what we do is we need to calculate the loss. So initially we passed all this information up to this layer. So now we will calculate what is the loss, because we have y1, and we have, sorry, let's and we have the original value of y. Let's take y hat as the predicted value and y1 as the original value. So why we have we have this error we can calculate from using y1 minus y hat. Then what happens is like we can calculate the loss, and our primary goal is to minimize this loss, because in any case our primary goal is to minimize the loss and try to bring our prediction close to this particular actual value. So that's what we do. And what we do is, once we complete the forward propagation, we try to calculate the last function and then use use that last function and then apply backward propagation, where we try to adjust the weights from backward propagation, nothing but adjusting these weights from this side this way through derivative transformations. And what happens is, like, in each case we are multiplying these derivatives with the last value which we are getting here, and then we adjust these weights in such a way that this particular function, I mean this particular output will be close to what actual value is. That's how this backward propagation works. And actually backward propagation takes a lot of time to explain. We need to have these derivative functions and derivative equations. So I request you to go through backward propagation whenever you get some time. Because if you don't understand this backward propagation, you don't understand different concepts like vanishing gradient problem. And to explain this backward propagation, you need to have a look at, you need to calculate the derivatives that will be calculated in every step. So go through that. I'm giving you a basic idea about how it works. So I mean, it's not the actual way it works, but you can simply understand that what we are doing is, like, once we calculate the loss, we are moving backward and trying to adjust the weights and biases in such a way that it will try to the output will try be will go move close to the actual value. So through that, what happens is, like, it will be understand these weights and biases will be adjusted to represent the actual information within the data. So that's about backward propagation. And coming to different types of neural network, there are multiple types of neural networks where there will be feed forward neural networks. Feed forward neural networks are the basic neural networks where there will be only feed forward, I mean forward propagation. We don't not be using any backward propagation here. And there is convolutional neural network. These convolution neural networks particularly work effectively for image data, but they also work more better for text data as well. So in some cases, they work more effectively for text data as well. And recurrent neural networks, these particular recurrent neural networks and LSTM are specialized for sequential data. I yesterday mentioned about the sequential data, right? Either time series data, or text data, or audio data. All these data are sequential data, because every data point that comes at time t minus 1, t plus 1 is dependent upon the data point that comes at t. I mean, and at the same time, the order of appearance of every feature or every word or every data is important here. I mean, every order of appearance of every word has some significance. For example, let's say I'm going to a bank. If I use bank on the bank near the river, or I'm going to a bank, river bank. So if you look at these two statements, in the first statement, it might be a financial institution which is on the banks of a river. But when it comes to second statement, we clearly know that river bank represents to some but the land which is associated with the river. So we need to understand. I mean, we need to look at every word has a timestamp associated with it, and and the approach order of this words is more important when it comes to sequential data, which is same for both time series data as well as text data and audio data as well. So that's why and these RNNs are particularly suited for sequential data, and they work better in time series forecasting solutions as well as text data, and also for speech recognition data also. Similar is the kind with LSTMs. LSTMs are kind of more advanced than RNNs, with which deals with the problem that RNNs was facing. And the transformers networks is currently state of art technology, which was developed by Google, and it was released in a paper called "Attention is All You Need," where this attention mechanism and self-attention mechanism were introduced, and I mean, not introduced, were used extensively within this one. And multiple encoder and decoder structures were connected, and these transformers were built to this particular transformers architecture were initially launched to machine translation, but later they performed more effectively on different text tasks like generating text, text sentiment, text classification, or name entry recognition, any of these NLU or NLP tasks. So they have been working effectively on these text tasks, and even these language models has these transformers stacked, multiple transformers stacked while building these language models. So they have this transformers architecture inherently within them. And the next one is autoencoders. This majorly used to deal with unsupervised data, I mean unsupervised machine learning tasks to deal with dimensional detection and anomaly detection. And they are also slightly advanced. And there is another advanced one for autoencoders, which is variational autoencoders or VAE. So these are different types of neural networks. Coming to different NLP tasks, I mean, this particular deep learning is not only for natural language processing, it is also for computer vision and speech, text, or any kind of data. When it comes to NLP data, there are multiple different. I will try to skip this fast because it's already 8:15. So there are different types of NLP problems. One is text classification, where our goal is to assign a label. Like for example, it can be sentiment, or it can be classifying a document, or it can be maybe email spam, or anything you can, I mean, anything where you can label the text data. It will be classification data. There are initially the different techniques like bag of words, TF-IDF, word embeddings were used, and now transformers are used extensively. And another NLP problem is name entity recognition, where I try to identify entities like people, or companies, or locations, or cities, or countries, or dates, or different things. Like for example, if you have an large corpus of medical data, and you want to extract disease names that are available, or I mean, you want to extract disease names into a dictionary, and medicine names into a dictionary, symptoms into a dictionary, then you will go with this NER, named entity recognition models. And generally, earlier rule-based models were used, and later hidden Markov models were used for this one. And now deep learning is used widely with LSTMs, and even language models are also language models, and transformers are also used extensively for name entity recognition. And another thing is part of speech tagging. Like if you want to assign, you have text data and you want to assign part of speech to that one, then you use this kind of problem. So same is the case where you use Markov models, and bi-LSTM networks, and transformers. And another important machine learning problem, NLP problem, is machine translation, where we translate text from one language to other language. And there is the initially statistical techniques were used to translate machines, and then later neural networks were used to do translate this one, where sequence to sequence and transformer models were introduced, like BERT and Robota or GPT. And now language models are used for machine translation. And there is another text generation, natural language processing. The problems which you are seeing in ChatGPT, where you ask a question and it generates text, is text generation problem. One thing, if you observe while using ChatGPT, if you observe, text is generated word by word. It's not like it will generate all the text and it will generate you the text. What happens behind it is it will generate word upon one word after another word. This how these text generation models work. Initially, LSTMs and RNNs were widely used for text generation. As I told, they were facing this vanishing gradient problem. And with the introduction of transformers and ChatGPT or GPT models, and this text generation become more effective. And now you can see how well they are performing. Even they are generating code. Or now you can see multi models also right now being generated, which can deal with text as well as image, as well as video and audio data simultaneously. And another natural NLP problem is question answer system, where you ask a question and it will try to generate response. This became more extensive. I mean, these solutions are being used widely in industry right now. For example, you have an internal database. Let's say you have patents in your company, and you want to generate some information from the database. You can't give that data outside and ask questions on top of that. Well, let's say it's around thousands of pages. You can go to each page and look for the information which you want. So for that one, what happens is, like these language models or transformer models, what they do is they will create embeddings of your text. And then when you ask a questions, by understanding the similarity between your question and then the text embeddings that are stored somewhere within the databases, it will try to generate the context from that particular embeddings, and then use that text to generate response for your questions. So majority of techniques use sequence to sequence models, transformers, and language models are used widely to solve this question answer problems. And one of the technique you might have been hearing is retrieval augment generation, that's related to this question answer system solution using language models. And then another problem is summarization. You will be having a large data and you want to summarize that information. Like for example, you have 10 pages of text that is available with you, but you don't want to use that one, and you want to summarize that information into concise format. So then you apply these summarization techniques, and they initially they were like LexRank and TF-IDF, but now most of them are using transformer based models, and this particularly these language models work effectively in these summarization problems as well. And another problem statement is text similarity. Like this is kind of intermediate step in some cases, and it is kind of our final problem statement in some cases, because this text similarity is used in order to generate embeddings to perform other activities. Like for example, if you want to do sentiment analysis, you can use this text similarity approach to create embeddings, and then use that embeddings to create your final application to do another problem like question answer systems, or text generation systems, or classification systems. So it's kind of intermediate as well as final output on its own. So now let's go to the coding part. So today we'll be discussing two notebooks. One notebook is related to general traditional natural language processing techniques, and another notebook will be related to kind of using this transformers model from Hugging Face. And I will also show you how to directly make prediction from make prediction from the model from by using the model that is already deployed in Hugging Face. Anyone, any questions so far? Because we completed this text information. So do you have any questions? I mean, I can understand this backward propagation and these forward propagation activation functions, and what happens within these neural networks is kind of confusing for you. So I mean, if I have to explain, it takes at least 2 to 3 hours, minimum of 2 to 3 hours for that particular backward propagation itself, because we need to go through different equations and we need to derive the equation so that you will understand why this will work, and why these values go to zero, or why this value the problems appear while doing the backward propagation. So that's why I'm unable to deal with that one right now. And if you ask me questions, or I will might be able to explain you in a better way, because I had to concise the information to make it fast. So if you have any question related to that, please go ahead and ask. Okay, I guess you don't have any question, or you don't want to ask any question. Uh, So we are using TensorFlow for the in this model, but TensorFlow it will be used for neural networks. And remember this TensorFlow and PyTorch. TensorFlow and PyTorch are extensively used in deep learning algorithms. And you will be, if you are working on deep learning models, you will be using these two libraries very extensively. And they this particular there is another, there is another library which is actually inbuilt in TensorFlow right now. If you install TensorFlow, in most of the cases Keras will also come into role. There is another Keras library which you need to use while training deep learning models. But in most of the cases, when you install TensorFlow, I guess by default Keras is also installed right now. I mean, earlier it was we need to install both the packages, but now it's inbuilt with TensorFlow. And another thing is the version dependencies. You will be facing a lot of issues with version dependencies. For example, to deal with this particular problem, I need to use TensorFlow version less than 2.11, because if I use version 2 greater than 2.1, 2.11, I'm facing issues. And another when I use this TensorFlow version 2.11, what is happening is like I have to use NumPy version less than 2. current latest version of NumPy is greater than 2. And if I use latest version of NumPy, and if I want to insert TensorFlow less than 2.11, what happens is there will be dependency conflicts, and it will not be able to load the libraries effectively. We'll not be able to load the libraries, and we'll be getting frequent errors. So that is one thing. And if something is working, try to whenever you are working on a project, and try to create separate virtual environment for that one. Like for example, in your new company, or whenever you go to a company, if you are working on some project, if you are working on two projects simultaneously, create one virtual environment for one project and another virtual environment for another project, and then try to keep the dependencies, or the library dependencies is nothing but the libraries which you will be using within this project. So try to separate these two dependencies, and keep the dependencies segregated within that environment itself, so that you will not have dependency issues, and you don't need to frequently go and check what is the issue, and how to solve that particular dependency issue, and keep on reinstalling, uninstalling, and installing these libraries. So for that's what happened in my case also. As soon as I went for TensorFlow 2.11, I was getting an error because my NumPy version was 2 point something, and so I had to degrade my NumPy version to 1 point less than 2. So that's why I used 1.26.26.4, which was the stable version available in NumPy at this point of time. I mean below version 2. So yeah, that is one thing I wanted to tell you. And even I would recommend you to start doing creating virtual environments, and using virtual environments while working on projects which you try to push to your Git repo in order to showcase your skill level. Because when you use virtual environments, it will show you the more professionalism to whoever looks at your code. So that's one recommendation I will give you, so that you will get habituated, and they will try to keep your dependencies in requirements text. And then whenever someone wants to run that one, they will just run that requirements text, and then they will import all the libraries without facing any issue with dependencies. Now going to the libraries, here we will be using TensorFlow and Keras. So these models is nothing but sequential models, are nothing but neural layers. And LSTM, as I already mentioned, is LSTM neural network, which we'll be using, which we can call and use in our network architecture. Dense layer is a layer network where we can specify how many neurons should be there within that particular layer. And this dropout is one of the concept in order to regularize this particular, I mean, deal with the overfitting of neural networks. I will not be able to explain this right now, because it again is an concept within that one. So for this time being, consider that this is used for regularization, and deal with overfitting of the model. And these embeddings are nothing but because text cannot be understood by the models, we need to convert them into embeddings, which will be used by the model to understand the importance of that particular feature, or word or text information that is being passed to the model. So any questions so far? No, I guess so. um, Now we will be working with sentiment analysis problem statement. In both the cases, we'll be using only sentiment analysis, which is nothing but classification problem. So sentiment analysis can be by binary classification, or multi-class classification as well. Because sometimes what happens is, like, sentiments can be generally negative or positive, or negative, neutral, and positive, or sometimes can be very negative, negative, neutral, positive, and highly positive. So depending upon the problem or requirement, you can make changes to your design of your network. So in this case, we will be using sentiment. We'll be using Twitter tweets data to predict sentiment of an airline, sentiment of airline tweet data. So we'll use that to predict what is if a text data or if a tweet is being passed to the model. It should be in a position to predict if that particular tweet is positive or not. The same approach can be applied to product classes, product review sentiment analysis, or book review sentiment analysis, or movie review sentiment analysis. Anything. I mean, whenever if you want to do classification or analysis, you can apply this one, and then this model will work effectively on top of that one. So if you want to use your own data, just change the data here and approach the process. Because if you see that in order to deal with these things, one important thing you need to understand while dealing with natural language processing is that your text will have a lot of unnecessary characters. Like for example, if you look at this text here, you don't, I mean, this particular at the rate of doesn't have any impact or any importance in deciding the sentiment of a text. Or there will be some HTTPS links which doesn't have any impact on your which doesn't have any impact on understanding the or which doesn't have any impact on the sentiment. So what you need to do is you need to clean all this information before you use that information, because it's unnecessary to pass this information to the model. So you need to perform some extensive, in most of the cases, some extensive cleaning process to prepare the data before training the model. But right now, if you take a language model, what happens is you don't need to deal with this cleaning of text, because it will understand, the language models are capable enough to understand whether that particular character is important or not, or that particular word have any significance, or is a deciding factor in understanding if the sentiment will be positive or negative. So they are capable enough to deal with that one. But the problem is, what happens is, like with every unnecessary character, you are increasing the number of tokens, and you will be charged. I mean, probably right now you might have been using ChatGPT as an question answer system, but when you are trying to build a solution, you have to use API calls. So when you are using API calls, you will be charged for per token, and that means every token will be associated with some amount of dollars. And by using extra text or unnecessary extra text, you are losing money. You are paying extra money to the API call, so which is unnecessary, and which will create a lot of waste. So before performing any NLP task, it would be better to to clean the data extensively, so that whatever the data that is required should be only should go to the model. Okay. If you look at this data here, we have tweet ID, which is not important to us, because every tweet will be uniquely assigned with one ID. And see, for example, if you want to build this as an application, you have a Twitter API where you can give some keywords to extract that tweets and and that information, and then pass to your pipeline, so that what happens is, like, whatever tweet that comes into this one, it will be able to make prediction. Let's take some movie released today, and you want to build an application which will take all the tweets related to that movie, and then pass that to a model where it will keep on predicting if that tweet is positive or negative. And then it will probably take the geography of that particular tweet, and then use that information to see in which localities there is more positive feedback, in which localities there is more negative feedback. And generally you will understand geographical distributions, are what kind of people are more giving more positive reviews. I mean, this might be for a movie, or this might be for a product, or anything. I mean, you can build such an application which can showcase your skills related to this one, where you can create a pipeline where by using Twitter API. Twitter API is free of cost. You can create an account and then use that. You can take live data to pass that to your model, where it will make predictions, and it can give you overall feedback in this time period, or in this time period far from this particular geographical location. So you can build an application like that. So here the data has tweet ID, and then the sentiment, which is our predict target variable here, and then this is the sentiment confidence score. Like for example, we are telling like this particular sentiment is neutral, but what is the confidence level of that particular tweet, or what is the probability with which this particular sentiment is being predicted. So this confidence interval is more important, because if you see here, this strongly says that the model is more confident enough that I mean, not the model, we are, I mean, this is prepared by manually. So we are confidently telling that this belongs to, this has highest confidence interval, and this is for sure neutral tweet. And if you look at this one, the confidence interval for this particular tweet is comparatively low. So we might not be able to consider this one, because it's comparatively low. I mean, so we might not go with this kind of confidence interval when we deal with our particular models. So we can also generate confidence intervals as well when we train our models. And these reasons and all are created by, I mean, depending upon your requirement, you can create these things. And this is airline name, so there will be different airline names, and you can also create a report where what is the overall sentiment of this sentiment for this particular airlines. And what about you can also create a report where for every airlines, what is the sentiment distributed across geographical locations, and you can give that to them. And then the person who tweeted the name, and what is the text that was tweeted, and when was the tweet created. But we don't need all this information. We'll be using sentiment and the text that is being the tweet text that is tweeted by the person. So these are all the columns that are there in that particular data. So yeah, as I already mentioned you, we will be only using text data and sentiment data, because we don't need other information to train our model. So we have this information, and we have this information. Now let's see how each tweet looks like, because we need to know what is the information that's being there in the text, so that we can at least understand if whatever the information we are trying to, I mean, what is the quantum of cleaning we need to do on top of this text data. And because when we write a function, we need to automate it so that all the tweets will pass through that one, and we get finally the cleaned text, so that that can be used to train our model. So let's take the first tweet here. So you can see we don't need Virgin America. You have added commercials to the experience tacky. Okay, what about the second one? I can do this. So where is the tweet? Yeah. Now you can see it's really aggressive to blast organizer, entertainment and guest. So all this and these has to be removed. These terms has to be removed, so that only important information is being passed to that model. And one important thing you need to know, yeah, we'll discuss that one while we go through the training of different while applying different approaches. 200 website is done, and I'm trying to check in. Yeah, so this is how the text looks like. Mostly we need to remove these unnecessary what are the characters that are available within this one. I didn't find any hyperlinks within the tweets. So yeah, let's try and see what happens. And now here what we are trying to do is we are making this as binary problem statement, and we are dropping all the tweets related to neutral, and we are keeping only positive and negative tweets, because we are creating binary sentiment analysis problem here. So now you can see we have 9178 negative tweets and 2363 positive tweets. So when this natural language processing started, the initial approach was to solve through rule-based approach. Like for example, I mean, text block doesn't work in this way. What happens is like they will use polarity to understand the sentiment of that particular text that is available, that is being passed to the model. There will be some rules which are created, and then we calculate polarity like whether it's towards good feedback or it's towards bad feedback, and then we use that information, that polarity score, in order to rank whether a particular text is positive or negative. So this is how this text block works, and there are certain rules written in that one, and certain polarity values that will be calculated for each text, and then that particular values, the polarity values will be used to decide whether a particular tweet is positive or negative. Right now, if you take this case here, you can see that what we're doing is we are calculating the polarity value here, and then we are telling like if the sentiment is greater than zero, positive; if sentiment is negative, less than zero, negative, then return neutral. So now that's how it's generating this sentiment. In this case, what happens is like in majority of cases this might not work effectively, because the rules might not be applicable for everyone, because there will be sarcasm associated with the information. There will be some text which might which contains both good as well as bad scores. Like for example, how these rule based systems work is like if there are two or three more goods and one bad, it will sum up all these values. So obviously the total value is two goods, so let's assign some better positive value to that one. Let's assign some score of greater than 0 point or greater than 0 value for this. So the sentiment will be positive. Similarly, what happens is if there are three bads and one good, then it will assign negative value. But if you look at this, if you look at a tweet where it says like there were a lot of airlines where I had negative issues and they didn't resolve that issues effectively, but Virgin Airlines was one of the best airlines which solved the problem. Here, if you look at the tweet, you can see there are two negative terms and then one positive term, and obviously it doesn't understand the nature of this tweet, and what happens is like it will just give you the sentiment as negative based upon the scores. So that's how they were not working with they are not effectively dealing with sentiment analysis or classification task, and they were not, I mean, sentiment analysis, and they were not effective in dealing with the problem. So one of the major problem was, I mean, they were unable to deal with sarcasm, slang, or context, and they also have limited vocabulary, and they rely on fixed rules. So obviously, whenever you are dealing with a rule-based system, that might not have the flexibility to deal with some information which has infinite as the limitation, because text data has infinity as limitation. You can say, like, I mean, you can consider infinity as limitation because a single word can be used in multiple ways. So obviously, they had huge limitations. And then next came this bag of words technique, where we try to find out what is the total, we try to calculate, create a bag of all the words that are presented in the text. And then based on that information, we try to predict if that particular information is positive or negative based by using an algorithm on top of machine learning algorithm on top of that one. And but it was not working effective because it was not taking semantic information within that one, and at the same time it was assigning a lot of information to unnecessary words. Like for example, there will be some words which will keep on repeating, because here you can see Virgin Airlines is being repeated multiple times. So if this particular Virgin Airlines will be associated a lot of value to that one, because it's appearing in all the tweets, and it might be appearing in every tweet multiple times, but it actually that doesn't have any significance in deciding the sentiment of that particular text. So this is how it was facing issues. And then came this TF-IDF vector approach, where what happened is this is vectorizer, and where was the TF-IDF? I didn't include TF-IDF in this. Okay, I will show you TF-IDF. Just let me share my other screen. So now if you look at this one here, TF-IDF. Not even in this one. Somehow I missed the TF-IDF. Okay, I will explain you. So what happens in case of TF-IDF is it tries to segregate the words and assign some value to the words based upon the target variable, and then it applies an inverse document frequency where it will assign less weight if that particular word is being repeated in all the tweets. So if it's appearing in all the tweets, then that means it's not a decision factor that is deciding that particular sentiment, but it's a common word that's being used in the entire document. So if the word is being repeated in the entire document, means document in the sense here what happens is every row is considered as a document, and if entire all the rows is having this particular word, that means it is a common word and doesn't have any significance in making the decision towards this particular sentiment analysis. So it will reduce the weightage of that particular word. So this is how TF-IDF works, and it was able to understand, it was able to deal with the problem which bag of words was facing, and then was working comparatively effectively. And what happens is like either with bag of words or TF-IDF, what we are ideally doing is we are creating an feature set, and by creating the value associated with each word in that particular text data, and then we have our target variable. So pass these features as feature set to an machine learning algorithm and try to make predictions or train the model to understand the patterns are the features that decide if a sentiment is good or not. And let me share that original one which I was working with. So after this rule-based approach, bag of words, and then there was this TF-IDF approach, which was, I mean, TF-IDF you can use in other cases as well. I have seen an use case where, in order to understand whether a hotel will be booked or not, they used along with other information, they used this TF-IDF to give the reviews or feedback from the customers to add that information to decide whether that hotel will be booked or not by some of the company which was operating into these holidays. So it's not like it will be used for sentiment analysis at text classification only. There are multiple ways to use that one. And then after this is the machine learning approach where we try to create features from the text data by encoding. Here what we are doing is like we are encoding the sentiment, because as I already mentioned you, we need to first convert them into numbers where we encode the sentiments into either 0 or 1 depending upon positive or negative feedback. And then we also encode our tweet data. We create embeddings for our tweet data by using vectorizer for that. Here, in the first step, what we are doing is we are encoding our sentiment information, and then we are using vectorizer where it will create vectors. Vectors are nothing but matrices for that particular matrix representation of a particular word within a corpus. Like for example, you have a corpus of a big corpus of a dictionary, and then you create an matrix representation of that particular word within n by n dimension of where n will be then n will be decided by when where n will be the length of that corpus, and that particular word will be represented within a particular space of n dimensional matrix. And we create that vectorizer for all the text, and then use that vectorized information or vectorized data, which is a combination of matrices within our data to train our machine learning model. So now here we are using this text in vectorized text, and then using our encoded sentiment to train our model using multinomial naive Bayes algorithm. And then what here it does is like it will try to understand the representation or approach of a particular word within within a single text, and it tries to look at this particular text as a representation of different vectors of words, and then use that to try to use that to understand the changes in the patterns for different sentiments. this is how this is how machine learning approach works, where you will be creating features by vectorizing the text data that is available with you, or you can use even TF-IDF vectorization as well in order to convert your text into numerical representations. And the more advanced one when compared with this vectorized is vector embeddings, where every word is represented in n by n dimension, where that particular word will be having representations or values associated with different dimensions. Let's take, for example, the word bank will be having a different representation value in when it comes in the financial context, and it will be having different value in the context of water. Or let's take and at the same time the man or woman will be having different values that are associated with it, whereas the value of king and queen will be king will be close to a representation of man in this aristocracy context, and queen will be closest to woman in the same context. So what happens is like this particular representation will capture semantic information from the textual corpus, and it will be able to understand whether this particular information I mean, what is the context in which this particular word is being used, because a word in a context will have different meanings, whereas a word in a different context will have different meaning. Yeah, Shivani, please go ahead if you have a question. I hope that was by mistake. The next version was, hello. Did anyone speak? Did anyone say something? So yeah, so earlier they used to do TF-IDF vector or another vectorizers which were used to create these features to train the model. But the more advanced one was vector embeddings, which are being used in language models as well. I mean, along with language models, and then what happens is like, for example, these two lines. Like for example, let's take I like pizza, and pizza is very good. So these two will have closest vector values, because these two represent the similar kind of meaning. So this is how this context information is being extracted from the text corpus, and then use this information in order to capture the actual meaning of actual context in which the particular text is being written. So this word embeddings will work more effectively when compared with previous approaches. And there are generally there are two vector embeddings, like both-to-back embeddings and glow embeddings, that are extensively used. And later, let me see if I use that one. No. Yeah, later, then we started using these neural networks like RNNs and LSTMs. Before RNNs and LSTMs, there were some traditional neural network layers that were built in order to train neural networks and to solve these NLP problems. Like for example, if you take this approach where we are using neural networks, we are using normal neural network approach, where this is where, so initially we are creating our data, and as I already mentioned you, we need to convert our text in our predictions into numerical format. So obviously we are encoding the information. And initially what we do is like we tokenize the information. That means we are converting our words into tokens, sorry, our text into tokens. That means if you have a text, let's say I want to go to a movie, then each word will be, the text will be split into individual tokens, like I want to go to a movie, and each one will be a single token. And if you remember, I mentioned you that when we have different lengths of text, how will we deal with this one? So when we vectorize this information, when we convert this text into some numerical representations, what happens is like there will be some value associated with each word, and there won't be zero value. So we use that zero value to pad this sequence to match the number of to match the length of the text which we want to pass to the model. Let's say I want to limit the maximum length of the text, or to limit the length of the text that will be going to the model as 100. Then that means we'll be having 100 tokens only, or 100 tokens in every text that will be passed to the model. Even if you have 10 words, there will be 100 zeros added to the text, added to this particular text vector, so that that information will not have any information, but similar length of text will be passed to the model. You can either add these values at the end of your text or at the start of your text, depending upon your interest or your approach. So that's what one thing you will be doing. And then once we create the tokens, then we create these sequences. And sequences are nothing but adding all these tokens, and then forming the token sequence for these text that will be for every row. And then we pad the sequences, because we want here, if you remember this one, if I already mentioned you, we need to decide what will be the maximum length of the text that we pass to the model. So here we are deciding maximum length as 50. Even if the text has more than 50, then obviously it will be shortened to 50 by removing some words that will come later. This again you can do either you can cut the words at the initial, or you can cut the words at the end of your sentence. So here what we will be doing is like, if any text is less than 50, then it applies padding. That means padding is nothing but adding these zeros, or some words which will not have any impact on which will be common. I mean, in general, we'll be adding zero padding. So consider that zero as the padding value which we'll use for padding sequences. So once you prepare your text, you need to now define your neural network architecture. So what we are telling is, we are telling sequential network, that means feed forward network. We are telling that we are going to create an sequential network where there will be input text initially, and then there will be hidden layers, and then there will be output layer. Now I need to define what will be the number of hidden layers, and then what will be the dimension of input that will be passed to my input, and what will be the output dimension, and what will be the input length, and all this information has to be passed to this information, because depending upon this input, the number of, if you remember this one, there will be this input dimension is nothing but total number of input features you will be passing to hidden layers. Here we are specifying 10,000 as our number. That means we are passing 10,000 input features to our hidden layers. That means we'll be passing 10,000 feature values to our first hidden layer. And output dimension is 16, because we have the final output will be having 16 output layers which will be used, and we are restricting our input length to 50. And we are flattening that information, and then these two are the dense layers. Based on this, you can tell that this is I have one input layer, one hidden layer, and one output layer. You can see this one. So here what happens is, this particular final output layer will be having only one neuron, and the activation function will be sigmoid activation function, because sigmoid will be used when you have binary classification problem, and our problem is binary classification problem here. And if you look at this one, I'm using 16 neurons in first hidden layer, and one neuron in output layer here. You can add any number of hidden layers, depending upon your requirement. You can change this number here. You can change this to 100, or you can add one more dense layer, and then in between you can add dropout option. Let me add 16 again. You can change your activation function as well if you want. So you can, depending upon your requirement, you can change this. And once you create your model and you are assigning model to this one, you need to compile your model by using, you need to specify what is the optimizer I'm going to use. In this case, we are using Adam optimizer. And what is the last function which I need to use in order to perform this backward propagation, and what is the metrics I need to measure, I need to use in order to adjust this weight value. So if you look at this one, here we are using binary cross entropy and accuracy as our metrics to perform backward propagation. Now, once we compile this model, our model will be finalized because the optimizer which will be used will be Adam, and we are using binary cross entropy as our last function to calculate the last values, and then using accuracy in order to adjust the weights to ensure that we are increasing the performance metrics in every epoch. So now we are fitting our data to this one, because we have our padded sequences, which is nothing but text data, and we have our labels, which is nothing but our output values, and we are specifying how many epochs we have to train. And verbose, you can ignore this one. These epochs are nothing but how many times you are passing your entire data, because every time you pass your data, it will learn something new. So you keep on passing data for every epoch, and for every epoch, what happens is like it will learn something new, and then the perform in general, with increase in every epoch, it will the performance will improve in neural networks. So that's how this will work. I think attendance link. Yeah, attendance link. So now what we are doing is like we are creating a function neural network sentiment to pass this text and to make predictions. So we are, because when we pass the text that needs to be predicted to the model which we trained, we need to pass it in a similar way in which input text was passed to the model while training the model. So same thing will be done here, and then we are passing the text to apply this function, and then we are passing this to predict our final prediction on top of that one. If you look at this one, if I run this, it's already run, but I will run this for the history. Where is the error? Yeah, I missed an. So once you start training the model, it will start training the model, and if you look at this one, accuracy keep on increasing with every step here. You can look at this one, your loss will decrease for every step, and accuracy will increase for every step. So this loss is nothing but binary cross entropy, which we used in this case. And in order to minimize the loss, it will be using Adam optimizer here, because optimizer is one thing which will be used to optimize the functions here. And this is nothing but the predictions that will be happening for our test data, which we are passing here. You can see that is happening, and it's predicting for all these one by one, and then it will generate, it will show you the output for each one. I thought I will show this one. Let me show you. So yeah, I want to show you this tokenizer here. You can see tokenizer is nothing but this one. For every word will be split into some, where every word will be divided, and then every word will be assigned some number, and then that number will be given to you, and you can see the encoded data here. This is how the data is passed to our model while training. So if you have the text here like this, then this text will be given a representation like this, and that information will be passed to the model here. And when it comes to padded sequences, where we apply embeddings, what happens is like this will be representation of each sentence here. So you can look at this sentence. As I already mentioned, you read there will be padding that will be applied. This is padding applied at the beginning. You can see there are all zeros, and then this is the information that we are passing to it. You can see 103, 575, 530, 1287, 2416. So when we have this tweet, then we are applying padding to that one by using 0 as padding value, and then this is the padding sequence that will happen. This is where if you want to apply this LSTM network, I applied on top of this one. So initially it will be common for every case, and we are applying dropout to regularize the model, and then we are creating an LSTM network with 50 neurons here, and a dropout value of 50% here, and then we are adding on one more dropout layer, and then we are adding our final output layer, and we are comparing the model with Adam optimizer and binary cross entropy. And if we run this one, it takes some time because the model is very big here. If you want, you can run this one, and then we are passing this padded sequence and sentiment label to this and splitting the data here. and then fitting our information to this. You can look at the plot here, which shows you what is the validation accuracy and what is the training accuracy, which goes on increasing as we increase our number of epochs. And you can see the last values here. The last values will continue decreasing with the number of epochs, and we can understand by frequently passing the data, it will be able to understand more, extract more information from that one. So this is how we can predict text from using our label. Yeah, this is about this one, and I will show you how to do the same thing using transformers model. This will be kind of I wanted to show you this one because this is kind of advanced one, not this. Yeah, this one. You can ignore this Vader analysis for the time being, because this is also based upon a kind of bag of words approach and polarity approach. So ignore this part as of now. So here we are using some reviews here about this particular products, and then this is about data analysis. If you have some time, go through this one. I will give these notebooks to you. Go through this. It will give some information. I mean, initially we do some analysis on top of every data which we get. So for this one, you go through this one and try to understand what we try to do here. And NLTK is library where we have package data that is available for most of the words, and we need to download that one in order to use NLTK library. And it is widely used to create these tokenizers. Most of the tokenizers are created using this NLTK word. And then so if you look at this one, this is the text, and for the same text, if you want to create tokens, then it will create like this. So what is happening here is like you are segregating, I mean, you are separating this entire text into individual words here. And remember one thing, it's not that every time the tokens will be individual words that will make any sense. Sometimes the words might be split in such a way that they will be stemmed to the root word also. It might happen. It's not like it will be happening every time. Sometimes this can be a case. And this is point of speech tagging. I was mentioning you, right? So there's one more another use case where we do part of speech tagging. So NLTK can be used to do part of speech tagging, and Spacey is also one of the library which works effectively with this POS tagging. And this is like this for tagging only. So this is not that important at this time. Yes, I used the TF-IDF here. So now what I'm doing is, in this case, this particular approach uses TF-IDF to vectorize the data. And then on top of that, once it vectorizes the data, that means you are converting the text into numbers. And once you convert the text into numbers by using this vectorizer, then I mean, vector here numbers means we're not just converting the number value, we are creating some matrices here, and then use that information as features and train model by using a machine learning model here. So here we are passing that text, and even in this case also you can see the accuracy values are comparatively very good. You can uncomment this one if you want to predict something on top of your data. If you want to do that, you can, I will give you this, you can uncomment this. I am not connected to runtime. This is Vader sentiment scoring, which uses bag of words kind of technique, which uses Vader lexicon, where it has some words information with it, and then uses polarity score to understand whether the particular sentiment is positive or negative. So you can see the polarity scores for this. I am so happy. You can see the neutral value was some value, and positive also was associated with some value, and negative was zero because happy was there. So this is the worst thing ever. Again, we'll have negative values here. But the problem is it doesn't take into consideration that semantic meaning. These are the results, plotting of results. Now we go to this one is generalized neural networks. Here I'm using 64 neurons and using a dropout option and average pooling. This pooling will be, I will explain you this, not explain. I'll show you this pooling in CNN networks, which we'll discuss after this. And this is also neural network model, so you can go through this. I already explained this. So if you want to run this, you can run this. Try to experiment with this one. try to add more neurons, try to add more layers, and change the activation functions. There will be tan H activation function, there will be ReLU activation function, there can be sigmoid activation function. Change the optimizers while compiling the model, change the loss function, change the metrics, and change the batch size. By changing the batch size also, you can alter this one. Try to add batch normalization and see how it works. So I tried all these techniques so that you will have an idea about how these techniques work, and what is the importance of each technique. Because this particular, I mean, when you are appearing interviews for this data science roles or machine learning roles, most of the questions will be related to this one, normalizations, or why this activation function, what is activation function, what are different types of activation functions, what is the output of different activation functions, why should we use this one, and when which activation function will work effectively in what cases, what are different types of loss functions, what is preferred in what case, and what is batch normalization, what is dropout, what are the regulation techniques that you apply while building a neural network. So this all will be used. So that's why I added this neural network as well. That is the reason why, I mean, I can simply show you the latest approach, like calling Hugging Face model and then run the sentiment. But you need to understand what happens with neural network as well. That's why I try to include all these techniques, because when you go for interview, they will ask you what happened earlier and what is happening currently. Because if you don't know what happened earlier, you don't understand what is happening with the current trend or current latest techniques that are being useful. If you are a user, that is a different case, but you are a developer, so obviously you need to understand, you need to know what are the approaches that were followed earlier. And then this is LSTM again. So go through this, make changes, add one more LSTM. You can change this to RNN as well and try RNN also. And yeah, this is the robota pre-trained model. Remember this term, pre-trained model. Pre-trained models are already trained on a huge corpus. But robota, all these GPT, all these models are already trained on a huge corpus of data which is available in internet. That means they already have lot of they already were and already have a neural network within themselves, and they already learned some information from the text that is already available from a huge corpus of text. When I say huge, it's very huge, and that means they already have some information learned. Like for example, let's take a student who is going to either, I mean, who learned information till 10th class. So he knows that he already have accumulated lot of generalized information related to science, related to maths, related to history, related to geography, or related to multiple subjects, language and all. And when you so he is already an trained person, and he needs to be further fine tuned for different, like for example, if you want to do medicine, he will opt that particular specialization, he will focus more on biological topics. And if you want to opt for engineering, he will focus more on maths, physics, and these kind of concepts. And if you want to go for if you want to become a chartered accountant, he will focus more upon economics and all these concepts. So what we do with these pre-trained models are nothing but a person who was trained on a large corpus, but now we need to use this pre-trained model to fine tune this model for our particular task. For example, in this case, we need to fine tune this model for our sentiment analysis task. So that's what we do with these pre-trained models. Pre-trained models are already trained models that are available with us. And there is a concept called transfer learning, which uses pre-trained models. That means, let's take image. I mean, yeah, we'll discuss that image classification tomorrow. For the time being, we'll and transfer learning also tomorrow. For the time being, assume that pre-trained models already know some information, and we need to teach them the new things. So we already know some information. You already know some information you learned till your in your academic studies, and now you are trying to learn something else. So someone, maybe some institution or your company will be fine tuning you on the task which they want you to do. Like for example, if you are becoming a data scientist, what an institution will try train you is on the concept related to data science. Or if you joined a company as an data science developer, they will be giving you training related to their own projects and the techniques they will be applying on the data science techniques that will be applied on their own data. And when you are dealing when you are becoming a Java developer, when you are hired as a Java developer, your company will stress you, I mean, try to train you or polish you in mostly in Java that suits their requirement. So this is how we use pre-trained models in our case also. So for this one, we have transformers library. So from where we'll be using tokenizers and classifications and different the embeddings from this transformers library. So we'll be using auto tokenizer. Earlier we used to do this tokenizing manually. If you remember the way we did. Here, what happens is like we need to just call our tokenizer function and then pass our data to that one so that it will automatically get tokenized. And we need to specify which model it has to be, what type of auto, I mean, which models tokenizer you want to use. Because these tokenizers are model dependent. That means if I'm saying I'm using BERT model to fine tune my model, if I'm using BERT model to create my classification model, then I need to use tokenizer that was created by a BERT model. So that's why we need to clearly mention which model we want to use while calling the tokenizer here. So here, my model, I'm going to use this Robota based sentiment model, which is available in Transformers library. So I'm using this model, and then I'm telling like I'm calling I'm assigning the tokenizer to the auto tokenizer by trained by using that particular model, and then my model will be the same model which I'm calling here. So I need to mention like I'm doing this model for sequence classification. So I'm using this model from the pre-trained model that is which I already mentioned here. So your model will be loaded based upon this one, and your tokenizer will be loaded based upon this one. That means here it will download the weights and the information that is required for this particular task for this particular related pre-trained model. And then what we do is ignore this part. We don't need this information. And then to generate our encoded text, we are using our tokenizer and passing a text related to that one. And the resultant will be tensor, PyTorch tensors, tensor values. Tensors are nothing but matrices. So that will be, which contains numbers related to this particular tokenized data. You can see here this final output. Let me see if you have encoded text here. So that it will give you an idea. Yeah, it's already closed. Okay, try to look at this encoded text. You will get an understanding of, you will understand what I am trying to say. You will look at the text in a different way when compared with the text which we used earlier. I mean, it will be in a matrix representation format, and then that encoded text is passed to our model, and then our model is trained on top of that one, and we are making predictions on top of the data that's available here. So here, this is comparison of these two. Yeah. So once we train the model and we can save our values from here and then use that model. When if you want to fine tune the model, we can fine tune the model on top of this one, where some of the weights that are associated with this pre-trained model will be altered or adjusted, and then that information will be used to. We can save that information as our own model and deploy these weights to our application and use that model as our own model. And when it comes to Hugging, I mentioned that Hugging Face model, right? The currently you can see these models. We can directly call the pipeline, and then we can just pass the text to the. We can directly call sentiment analysis pipeline from the transformers or for Hugging Face, and then you can just pass text to this. So that what happens is like it will predict. It will directly give the score. You don't need to do all these text encodings and everything from it. You just need to just call the pipeline function from that one, which already includes all this information. There are different pipelines, right? Let me try and show you what are the pipelines available. If you see this one, this is called as Hugging Face website, where you can find a lot of models that are deployed here, and at the same time, there's a lot of playground scopes where you can call your required pipeline. So if you want to do text classification, we had to pass an text classification pipeline. And if you want to do named entity recognition, then you need to pass name entity recognition as pipeline name. Depending upon your requirement, you need to you need to call that particular pipeline, and it will automatically work behind the scenes. Whereas earlier, what we're doing is we are training our model. Even in this case, I haven't fine tuned this model here. Let me show. Sentiment analysis, yes. So if you look at this case here, I'm not actually fine tuning the model. I'm just calling this model and where is that? Okay, wrong notebook. Yeah, if you look at this one, here I'm not actually fine tuning the model. What I'm trying to do is I'm just calling the model and then using order tokenizer to convert my data into tokens that uses the tokenizer which was trained by the model I'm calling here. I'm just simply using this model which is available in the Hugging Face, and then calling that model and converting my text into the tokens data which is available, which can be understood by which was trained by using the model which I am calling from here, and then making predictions on top of that one. But there is another way which can be used in order to fine tune your model. That means, let's say you have your own data which cannot be sent outside, so you can't you give that data to open source and ask them to train the model. So what you can do is, this model haven't seen this data, so now you want your model to understand this data. So what you can do is, you can either apply an extra layer on top of on top of before the final layer, or some extra layers, so that your information from your text is also taken added to the network weights and the bases, and this information is also considered while making any prediction on top of the text data which is being passed to it. So what happens is, like, so far the model was trained on generalized data, but now when you fine tune the model, what you are doing is, when you are fine tuning, you are adjusting the weights that meets the needs of your data. Now it understood the context of the information in generalized data, but when you are passing your data to fine tune the model, what happens is, like, it will try to understand the same information in the context of your information, so that it will alter the weights to suit the patterns within your data, and that final model will be a model which is suited for your data. And this model will not work effectively with some data which doesn't have any relation to the data that which doesn't have a relation with your data. So that's why, I mean, if you want to have your own personalized model, then you can use these baseline models, and then fine tune these models on top of your data, so that it will be a new model for you. So that is one other option you can do to make your own personalized models. So this is one of the case where even language models can also be fine tuned on top of your data. So that's where you can add the tinge of your own information to the model. Like, let's say, for example, if you ask a question about something related to patent data of a company, none of the chat GPT or Llama models will not be able to respond to that question, because they have never seen any information related to that data. But when you fine tune that lang model with your data, what happens is, like, it already factored in the information from the data that you have. And when you ask some question related to that one, it will take that information, and it will be able to effectively generate response based upon your particular data. So this fine tuning concept is one of the important concept. And when you get some time, go through that fine tuning concept. And there are different libraries that can be used for BERT and all. We can use Hugging Face and Transformers, or generally add a new layer to that one, or add a classification layer to convert BERT model into classification model. And or you can add you can adjust internal weights as well, already existing weights as well, or you can add multiple layers to make changes to the existing pre-trained model. So you can apply different approaches to fine tune the model to suit your needs, and then use that as your own model. So this is about fine tuning, and this is about natural language processing. Any questions so far you have? Tomorrow we'll discuss CNN, and we'll do image classification along with language models as well. And I will give you a glimpse about different techniques that are being used in that are being in demand right now, that are being used in industry. And you need to go through in depth about that particular concept. I will try to give you an overview about different terminologies and concepts related to language models as well. I will show you how to call models from Hugging Face, and use that to suit your needs. So we'll try to write code for calling models from Hugging Face, and then generating text, or try to see if we can generate we can create an retrieval augment generation solution by uploading a document of your own, and then generating response from the question. I will try to see, provided that Colab allows me that GPU. I will try to give that demonstration tomorrow along with the CNN. So our priority will be CNN, and for sure I will try to explain different terminologies and concepts related to language models as well. So any questions so far? If we don't have any questions, then we can end the session here. Sushmita, I think no one has any questions. So
So yeah, okay, sir. Even for me, there is no any questions. So sir, we'll wait for 2 minutes.
yeah,
So
sure,
if they have a question, they can ask.
sure.
Students, if you have any query, kindly ask it. So we'll wait for 2 more minutes. If you have any questions, you can just ask.
Sorry, regarding assignment, someone Sija was asking. For last two classes, I already provide these notebooks, and for these three classes, I will be providing the notebooks tomorrow, so that I can club all this information and I can give that to them. And assignments, I guess, we'll be giving at the end of tomorrow, I guess. Right, Susmita?
Yeah, yes, sir. Like tomorrow, they will be having an assignment from day 1 to day 15. So tomorrow for 1 hour, the test will be not for 1 hour, like 45 minutes.
Okay.
So yeah, on the same session, we will share the link students tomorrow at like 8:15. Sorry, the session start at 7:39. I mean
Right.
7:30, right? Around 9 o'clock, we will share. Okay, sir. If you don't have any question to address, you can drop the session.
Yeah, sure.
We'll wind up
Thank
for
you
the day.
everyone, and have a nice day.
Yeah, thank you, sir. We'll meet again by tomorrow at 7:30.
Yeah, bye.
Thank you. Yeah, students, I hope you all mark your attendance. So yeah, we are winding up for the day. Thank you all. Good night.